June 2017, Phoenix, Arizona. The heat climbed past 120 degrees Fahrenheit, and dozens of flights got canceled before they could even leave the ground. The official reason was thin air and extreme heat. But there was a second problem sitting quietly on the tarmac the whole time: the color of the planes themselves. Those regional jets couldn't fly because hot air is thin air, and thin air gives a wing less to push against. That part is physics, and there's nothing paint can do about it. But heat doesn't stop at the wings. It sits on the skin of the aircraft for hours, every single day, on every tarmac on Earth, from Phoenix to Dubai to Riyadh. And what color that skin happens to be decides how much of that heat actually gets in. Look at almost any airport in the world, and you'll notice the same pattern repeating over and over on aircraft that share almost nothing else in common. Budget carrier, luxury carrier, cargo plane, private jet, it doesn't matter. Almost every aircraft you see is white. Not by tradition, not by accident, by calculation. And once you start pulling on that thread, it turns out heat is only the first of four completely separate reasons the industry keeps arriving at the exact same answer.
Start with the obvious reason. White reflects sunlight. Black and darker colors absorb it. It's the same reason a black car turns into an oven in July, while a white one parked right next to it stays bearable. On an aircraft, that difference isn't a rough guess, it's measured. A black composite panel sitting in direct sun can climb past 160 degrees Fahrenheit, while the same panel painted white stays closer to 140. The structural limit for a lot of that material sits around 180 degrees.
That gap between 140 and 160 isn't comfort, it's margin. And margin is the only thing standing between normal operations and a component quietly failing years ahead of schedule. This matters even more for carriers like Emirates, Qatar Airways, and Etihad, whose aircraft spend entire afternoons baking on the tarmac in some of the hottest climates on the planet. Newer aircraft make the problem worse, not better. Planes like the Boeing 787 and Airbus A350 are built largely from carbon composite instead of aluminum. And composites handle heat far worse than metal ever did. White isn't decoration on these aircraft. It's thermal management, built directly into the livery.
Here's how seriously the industry takes that margin. In 2019, the White House wanted a bold new look for Air Force One, a darker red, white, and blue scheme, replacing the pale blue that had defined the plane since the Kennedy administration. You'd assume that if any aircraft on Earth could simply ignore a heat problem, it would be the one carrying the most protected person on the planet, on a budget measured in billions of dollars. It couldn't. Air Force engineers ran a thermal study and rejected the design outright. Officials said the darker paint on the aircraft's underside could push certain components past their certified temperature limits, triggering additional safety qualification testing before the plane could even fly. The bold livery got shelved for a scheme almost identical to the one it was replacing. Years later, a version of the darker design finally did return, but only after engineers added heat-reflective paint and kept the lighter, near-white panel exactly where the sensitive equipment sits underneath. Even with an unlimited budget and total authority.
Physics still got the final word on the color.
And then there's a problem you'll never notice from the ground. A plane's skin has to be inspected constantly for damage that can kill people. Hairline cracks, dents, corrosion, oil leak from a hydraulic line or an engine seal. Regulators require these checks on a strict schedule, sometimes before every single flight. And mechanics are trained to do it fast, under time pressure, often in poor lighting on a night shift.
On a white surface, a mechanic doing a routine walk-around with nothing more than a flashlight can spot a stain or a crack almost instantly because nothing else on the surface competes for their eye. on a fuselage covered in old color and heavy graphics, that exact same crack can sit hidden for an entire inspection cycle, camouflaged by the very design meant to make the plane stand out. In an industry where a single undetected fatigue crack has caused catastrophic failure before, that visibility isn't a bonus feature bolted on afterward. It's a safety system built directly into the paint job for free every single day, whether anyone on board ever thinks about it or not.
You might wonder why airlines don't skip paint altogether, since bare metal weighs even less than a coat of white. For decades, some of them did exactly that. American Airlines flew unpainted, polished aluminum for almost 60 years, specifically to save the weight, only switching to a fully painted silver livery in 2013. But option wasn't preference, it was materials. A polished aluminum fuselage gleams because bare metal reflects light like a mirror. A carbon composite fuselage, the material behind the 787 and the A350, comes out of the factory looking like dull, dark gray plastic, and no amount of buffing will ever make it shine. As the industry shifted from aluminum to composite, the bare metal option quietly disappeared, and white became the only remaining way to get most of the same benefits: cooler, lighter, cheaper to touch up, without needing a mirror finish that modern materials simply can't produce.
Now follow the money, because airplanes almost never stay with one owner for life. They get sold. They get leased for years, then leased again to somebody else entirely, sometimes on the other side of the planet, flying under a completely different name within a matter of weeks. Just over half of the world's commercial jets aren't even owned by the airline flying them. They belong to leasing companies renting them out the way you'd rent an apartment, moving them between carriers as demand shifts. Every time a plane changes hands, its paint usually has to change too. Stripping a fully colored livery down to bare metal and repainting from scratch is slow, expensive, and adds paint weight of its own, sometimes taking a plane out of service for days it could otherwise spend earning money in the air. Starting from a white base and swapping only the tail stripe and the logo is dramatically cheaper and faster. A full repaint on a commercial jet can run anywhere from $50,000 to $200,000, depending on the aircraft's size and the complexity of the new design. White isn't just a color, it's a resale strategy, engineered into the aircraft from the day it's delivered, long before anyone knows which airline will be flying it 5 or 10 years down the line.
And then there's the part almost nobody thinks about. Paint itself weighs something real. A full paint job on a commercial jet can add somewhere between 270 and 540 kilograms to the aircraft, roughly the same as putting 8 extra passengers on board for every single flight, for the entire life of the plane, silently burning extra fuel on every takeoff, whether the seats are full or not. White also happens to fade slower than most other colors, which means fewer repaints across the aircraft's lifespan, which means less weight, less downtime, and less money spent sitting in a plane hangar instead of in the air. The few airlines that break the rule pay for it directly. When Southwest Airlines unveiled its bold blue, red, and yellow heart livery in 2014, the design team had to actively balance that vibrant color against fuel efficiency the entire way through. EasyJet's one-off all-orange jet and Spirit Airlines' bright yellow fleet are treated as exceptions worth talking about precisely because they're rare. Every airline that chooses color is choosing to fight a weight and fuel problem that white simply never has. Put all 4 of those problems together: heat, inspection, resale, and weight, and white stops looking like a default setting nobody bothered to question. It starts looking like the closest thing commercial aviation has to a solved equation. One that gets quietly resolved on almost every aircraft delivered on every continent, decade after decade, by engineers and airlines who have never met each other and never needed to.
So, the next time you're sitting on a scorching tarmac, maybe somewhere like Phoenix in the middle of summer, waiting for your delayed flight to finally push back, look out at the plane's skin. It isn't white because someone decided it looked clean. It's white because it's cooler. It's white because it's safer to inspect.
It's white because it's cheaper to resell. It's white because it's lighter to fly. Nobody signed a contract for it. No aviation law demands it. And yet, somewhere between physics, safety, and money, an entire global industry quietly agreed on the same unclamorous decision. And it's been repeating it without a second thought on almost every runway on the planet.